An AFCI fault circuit interrupter, or AFCI combination device, is engineered to provide both AFCI fault protection and overcurrent protection within a singular unit. This dual functionality enables the device to safeguard against AFCI faults, as well as overloads and short circuits. AFCI faults are unintentional electrical discharges that can occur due to damaged wiring, loose connections, or faulty appliances. Overloads happen when too much current flows through a circuit, while short circuits occur when there is an unintended low-resistance path of current. In addition to AFCI combination devices, there are also devices that integrate AFCI protection with ground fault circuit interrupter, or GFCI, protection within a single breaker. These combined AFCI and GFCI breakers are generally implemented in locations that are prone to moisture or dampness, where both types of protection are mandated. A GFCI is a safety device that protects against electrical shock by monitoring the current flowing in a circuit. If it detects a difference in current between the hot and neutral wires, it assumes that some of the current is leaking to ground and immediately trips the circuit. This leakage can occur when someone comes into contact with a live wire or a wet surface that is conducting electricity. To further illustrate, examples of AFCI combination devices include: firstly, square DQO AFCI and GFCI circuit breakers; secondly, General Electric, or G, AFCI and GFCI circuit breakers; and thirdly, Siemens AFCI and GFCI circuit breakers. AFCI/GFCI combination devices can be found, for example, as firstly, Eaton AFCI and GFCI circuit breakers; secondly, Leverton AFCI and GFCI circuit breakers; and thirdly, Murray AFCI and GFCI circuit breakers. Standard circuit breakers primarily offer overcurrent protection, safeguarding against excessive current flow that could damage wiring or equipment. AFCIs, on the other hand, specifically detect AFCI faults, which may not trigger a standard circuit breaker. GFCIs are designed to protect against ground faults, which are leakages of current to ground and can cause electrical shock. Combination AFCIs provide both overcurrent and AFCI fault protection in a single device, offering a more comprehensive safety solution. Similarly, AFCI/GFCI breakers combine AFCI fault and ground fault protection. It is important to understand the different types of protection offered by these devices to ensure that you are using the appropriate breakers for your specific application. The National Electrical Code, or NEC, mandates the use of AFCIs in many areas of the home to protect against AFCI faults. GFCI protection is also required in specific locations, such as bathrooms, kitchens, and outdoor areas, where there is a higher risk of electric shock. When selecting circuit breakers, it is crucial to consider the amperage rating of the circuit and the type of protection required. It is also important to choose quality products from reputable manufacturers to ensure reliable performance. Proper installation and maintenance are essential for the safe and effective operation of circuit breakers. Always consult with a qualified electrician for any electrical work to ensure that it is done correctly and safely. AFCIs and GFCIs work independently but complement each other in providing comprehensive electrical safety. An AFCI detects dangerous AFCI faults that could lead to electrical fires, while a GFCI protects against electrical shock by detecting ground faults. Using both types of devices provides a layered approach to electrical safety, protecting against a wider range of hazards. An AFCI monitors the electrical current for unusual patterns that indicate an AFCI fault. When an AFCI fault is detected, the AFCI quickly trips the circuit, cutting off the flow of electricity and preventing a potential fire. A GFCI monitors the balance of current between the hot and neutral wires. If it detects an imbalance, it assumes that current is leaking to ground and trips the circuit to prevent electric shock. Combination AFCI/GFCI breakers offer the convenience of both types of protection in a single device, simplifying installation and saving space in the electrical panel. When installing AFCIs or GFCIs, it is important to follow the manufacturer's instructions and local electrical codes. Proper wiring and grounding are essential for these devices to function correctly. Regular testing of AFCIs and GFCIs is also recommended to ensure that they are working properly. Test buttons are typically provided on the devices for this purpose. If an AFCI or GFCI trips frequently, it may indicate a problem with the circuit or the appliance connected to it. In such cases, it is important to investigate the cause of the tripping and take corrective action. This may involve repairing or replacing faulty wiring or appliances. It is always best to consult with a qualified electrician to diagnose and resolve any electrical issues. The use of AFCIs and GFCIs has significantly reduced the risk of electrical fires and electrical shock in homes and businesses. These devices are an important part of a comprehensive electrical safety plan. Understanding the principles behind AFCI and GFCI technology can help you make informed decisions about electrical safety in your home or workplace. Consider the specific needs and risks associated with different areas and applications to determine the appropriate level of protection. The NEC provides detailed requirements for the installation and use of AFCIs and GFCIs in various locations. Staying informed about these requirements can help ensure that your electrical system is safe and compliant. Remember that electrical work can be dangerous, and it is always best to consult with a qualified electrician for any complex tasks. Taking the necessary precautions can help prevent electrical accidents and protect yourself and others from harm. The cost of AFCIs and GFCIs has decreased over time, making them more accessible for homeowners and businesses. Investing in these safety devices is a worthwhile investment that can provide peace of mind and protect against potential hazards. As technology continues to evolve, AFCIs and GFCIs are becoming more sophisticated and reliable. Newer models offer improved detection capabilities and reduced nuisance tripping. Staying up to date with the latest advancements in electrical safety technology can help you make informed decisions about your electrical system. Always choose products that are listed by a reputable testing laboratory, such as Underwriters Laboratories, or all, to ensure that they meet safety standards. Proper grounding is essential for the effective operation of GFCIs. Make sure that your electrical system is properly grounded to minimize the risk of electric shock. Regularly inspect your electrical wiring and appliances for any signs of damage or wear. Replace any damaged components immediately to prevent electrical hazards. Avoid overloading electrical circuits by plugging too many devices into a single outlet. Use power strips with surge protection to protect sensitive electronic equipment from voltage spikes. Keep electrical cords away from water and other liquids to prevent electric shock. Never attempt to repair electrical equipment unless you are a qualified electrician. Always turn off the power at the circuit breaker before working on any electrical circuits. Use insulated tools when working with electricity to protect yourself from electric shock. Wear appropriate personal protective equipment, such as rubber gloves and safety glasses when working with electricity. Be aware of the location of overhead power lines and maintain a safe distance from them. Never climb trees or other objects that could bring you into contact with power lines. If you see a down power line, stay away from it and call the power company immediately. Teach children about electrical safety and the dangers of playing with electrical outlets and cords. Install tamper-resistant outlets to prevent children from inserting objects into electrical outlets. Use ground fault circuit interrupter protection for all outdoor electrical outlets. When using extension cords, make sure they are properly rated for the intended use and are in good condition. Do not run extension cords under rugs or furniture, as this can create a fire hazard. Unplug appliances when they are not in use to save energy and reduce the risk of electrical hazards. Have your electrical system inspected periodically by a qualified electrician to ensure that it is safe and up to code. Keeping your electrical system in good condition is essential for the safety of your home and family. By following these safety tips and using AFCIs and GFCIs, you can significantly reduce the risk of electrical accidents. It's also important to note that while AFCIs and GFCIs provide significant protection, they are not foolproof. They are designed to mitigate specific types of electrical hazards, but they may not prevent all electrical accidents. Therefore, it is essential to practice general electrical safety habits in addition to using these devices. For example, avoid using damaged or frayed electrical cords, do not overload circuits, and keep electrical appliances away from water. Regular maintenance of your electrical system is also crucial. This includes inspecting wiring outlets and appliances for any signs of damage or wear and tear. If you notice any problems such as flickering lights, frequently tripping breakers, or sparking outlets, it is important to have them addressed by a qualified electrician promptly. Ignoring these issues can lead to more serious electrical problems, including fires and electrical shocks. When renovating or remodeling your home, it is essential to ensure that all electrical work is done in accordance with local electrical codes. This includes obtaining the necessary permits and hiring a licensed electrician to perform the work. Improper electrical work can create significant safety hazards and may not be covered by your homeowner's insurance. In addition to AFCI's and GFCI's, surge protectors can also play an important role in protecting your electrical system and appliances. Surge protectors are designed to protect against voltage spikes, which can damage sensitive electronic equipment. They are particularly useful for protecting computers, televisions, and other electronic devices from power surges caused by lightning strikes or other electrical events. There are different types of surge protectors available, including whole-house surge protectors and individual surge protectors. Whole-house surge protectors are installed at the main electrical panel and protect the entire electrical system from voltage spikes. Individual surge protectors are plugged into outlets and protect individual appliances or devices. It is important to choose surge protectors that are properly rated for the intended use and that meet safety standards. When selecting a surge protector, look for a model with a high surge current rating, which indicates the amount of surge current that the device can handle. Also, make sure that the surge protector has a UL listing to ensure that it has been tested and meets safety requirements. Finally, remember that electrical safety is an ongoing responsibility. It requires diligence, awareness, and a commitment to following safe practices. By taking the necessary precautions and staying informed about electrical safety, you can protect yourself, your family, and your property from electrical hazards.